Welcome and thank you for joining us for our monthly webinar. This month, we are featuring an architectural analysis for better performance testing. Some key takeaways from this webinar will include providing a framework to analyze a software landscape from a performance perspective, providing an approach to reduce the guesswork and to improve the quality of performance test strategy, and to help to identify the key areas of performance risk. During this session, please keep your microphones on mute. Questions can be asked through the GoToWebinar menu bar located under the question functionality. We will answer questions at the end of the presentation, but you may submit them at any point throughout the session. In addition, at the conclusion of the webinar, you will be sent a survey. We truly value the opinions and feedback of our peers in the QA and IT community. If you have a few moments, we would greatly appreciate you filling it out. This webinar is sponsored by the Testing Consultancy, and we also call ourselves TTC for short. TTC is a global consulting firm that specializes in all things testing. We believe a successful digital transformation relies on having the right people, processes, and technology in place. As organizations shift from slow, costly, and high-risk manual testing to test automation with agile and DevOps processes, they can find testing to be a bottleneck in the software development lifecycle. We assist our clients to make these changes by providing modern software testing and quality engineering techniques such as test automation, test design optimization, performance testing, and other methods that will remove the bottleneck and enable organizations to make transformation from waterfall to agile to DevOps. In the next 40 minutes or so, you will learn from the first-hand experience of senior consultant Servali Arpana on how to truly achieve best practices when utilizing performance testing. Servali is a thought leader in the performance testing field and has spoken to audience at the Neotis PAC conference. She will help attendees understand the technical landscape as well as the business problems that many testers incur when starting their performance testing journey. Without further ado, I will pass it over to Servali to get the main event started.
Thank you, Carla. Sorry, just one moment, just having a technical glitch. Okay. Hope everyone is able to see my screen.
Yes, we're all set, Servali. Take it away.
Okay, cool. Thank you, Carla, for the introduction, and thank you, everyone, for taking time and joining this session. So Carla has already introduced me, but so I'm Shivali, and I've been working with TTC for a couple of years now, and I have been in performance testing space for a while now. So something which I found when I got started in performance testing space, but like learning tools is hard, but it is relatively easy because like we have like online manuals, tutorials, and courses, but learning process, I found it slightly difficult because these days everyone seems to be doing it their own way. But like I was fortunate enough to work alongside some really great people and learn a few things. So hopefully, I hope I can share a few things in today's webinar. So let's just move into our talk for today. Let me start with an example scenario, something very familiar scenario for all of us. So say we have a client who has come to us with a performance testing requirement. So let's just say this client is a major university in town, and the client is rolling out a new web portal for their students. So this is like going to be like a running example I'm going to use throughout the talk. Uh, so the functionality of this web portal is it basically allows the students to view their personal information or the academic information, like the grades or library loans, etc. Let's say some of this information is read-only to the students, but some of them, like the profile information, can be updated by the students. So this is the scenario we are dealing with. In the portal itself, let's say it's pretty basic. It has one web and app server and one database server. So we have, let's say we have a new performance tester going into the client side, and he did the workload modeling based on the number of students. He has come up with a peak load, and he has run some tests, and he has get the results. And the response time seems pretty good. Everyone was super happy, and the portal went live. So this is where things starting to fall apart. So basically, the students started to complain how slow the website is, the portal is. So what could have gone wrong in this scenario? Well, a lot of things could have gone wrong, but let's just say this could be the problem. So, oops, skipped ahead. So it's rarely a case that the application that we are testing is a standalone system running on its own without any integrations. It's hardly a case because businesses are complex, right? I mean, businesses use software for a lot of purposes. Like, for example, there might be a CRM system which holds all the customer or student information in this case, or there might be other ERP solutions which handles accounts payable, receivable, or billing systems. So there might be a lot of systems in the landscape, and all these systems constantly communicate with each other because they need to exchange information with each other. I mean, for this reason, like the perceived performance of one application could be dependent on the performance of the other applications in the landscape. So because, I mean, from the end user perspective, it doesn't really matter where the bottleneck is. If it's impacting their user experience, it's going to hurt clients' reputation or revenue or productivity. So that's why we need to take like a holistic approach to when conducting performance testing. We cannot conduct performance testing like in a black box approach. Even if we attempt to do like a black box approach, at least we should understand how all the boxes in the landscape are connecting with each other. So this is where analyzing solution architecture comes really handy. So in this presentation, I'd like to talk about like the approach or framework that I typically use when I start on a new engagement. So this exercise is basically taking a look at the big picture and analyzing the architecture and making sure that we really understand where the performance risks are and draft the performance strategy accordingly, instead of just straight away jumping ahead and start building the test scripts. So just to make it clear, this exercise is not a replacement for any other activities in the performance test cycle. Like we still need to do workload modeling, and we still need to build test scripts, we still need to do tests, and we still need to do analysis, everything we need to do. But this step comes before everything else, which makes all other activities in the life cycle more accurate and meaningful. And especially like if you're going as an external consultant to a new client site where you need to understand a lot of things in a short period of time, this hopefully could come handy. I mean, I'm not going to over-exaggerate it. It's not a brand new concept. Most of us do it. Maybe some of us don't do it, but hopefully this talk should provide some guidance and structure in terms of what to look for and to get most information out of the architecture documentation. So at least there are 5 different levels of information that I typically gather. So I call them like the context layer, consumer layer, infrastructure layer, communication layer, and the information layer. So in the subsequent slides, let's go into each of these layers in detail. So the first step in this architectural analysis approach is the analyzing the context layer of the architecture. So this step is all about understanding what has changed within the context of the release or the project that we are testing. Like when we say changes in the architecture, they could be like brand new components that were added into the landscape, because these components do not essentially have any prior performance benchmark, or there could be some existing components but have been modified to accommodate the requirements for this release. So we need to include these components for within the scope of our testing, because this is where majority of the uncertainty or the risk is in terms of performance. And also sometimes, even though some components are not changed, we need to include certain components for within the scope of our testing, because performance changes in one component can impact the performance of the other component. I mean, let's just say, see an example, and hopefully it all ties together. So this is like a simple basic block diagram architecture for the example scenario that we are talking about. So we have a web portal which is used by the students typically on a day-to-day basis. And this web portal fetches the information, the student information from this system and the course information from the course scheduling system through this integration layer and displays it to the students. Also, let's just say in the landscape, like we have an external system. This is outside the university, like a regulatory body that makes calls to the university infrastructure to get some grading related information. So let's say if you are deleting, if you are, if this is the scenario that we are working with, we can straight away say that the student web portal is a brand new component and has no performance information benchmark available. So it needs to be thoroughly tested. Whereas this integration layer, it is an existing component because let's say the regulatory body has been using it for a while now. So it's an existing component. We know how it's performing in production. But however, this component has been modified to extend it to include additional APIs for this student web portal requirements. So we have some uncertainty or the risk with this component. So this needs to be thoroughly tested as well. And these finally coming to these core systems, this one is a bit tricky because these haven't been changed in this release. Like there are no core changes, no functional changes, no infrastructure changes, nothing has been changed. However, if we like take a closer look at how all these components are connected, we can immediately say that these components are have performance risk associated with them, because after this release, these components are going to experience additional load coming from this web portal. So there is a chance that these components could become bottleneck, maybe because maybe when these components were designed years ago, maybe they weren't designed to scale with this additional load. So that's why we cannot simply stop or ignore the performance of these components. So this is why analyzing, taking the look at the big picture, it helps us make sure that we are not missing any key components, or as well as we can focus on the areas that are crucial. So this is how we analyze the context layer of the architecture. Moving on to the next layer, it's a consumer layer. So this step is about understanding who consumes these services of your software. Like in most cases, it's probably obvious, like real users. It can be internal staff or customers or students in this case. But there could be some not so obvious consumers, like there could be other integrating software systems that access the APIs and services exposed by your system and test. So they are also your consumers. Or they could be even like the batch processes that typically consume a lot of data and resources from your system under test. Understanding these different consumers of your software is really important because these are essentially the sources of load or the channels of incoming load, which is again another key determinant of performance risk. So going back to the example one more time, maybe when our performance tester guy, when he tested this system, maybe I think he might have like simulated only the load coming directly from students. He might have missed the load coming from the regulatory bodies or other sources of load. Without having full load, maybe the response times would have been real fast, tricking into thinking that everything is fine when it's not. Like, I'm not saying that we need to include every single channel that we see, but at least looking at the big picture will give us, we need to consider all the channels before we eliminate the non-key ones after analyzing the volumes and everything. So that's where workload modeling comes into play. So, so doing this activity will make sure that we don't miss any key sources of load and makes our workload modeling exercise more meaningful. So moving on to the next layer, it's the infrastructure layer. So this step is about understanding the physical architecture of the solution that we are dealing with. So it helps us understand where the components are physically hosted. So this is not like a comprehensive list, but I mean, just to give you an indication of what type of information that we look for, it could be things like whether it's the system is deployed on a physical machine or on a virtual machine, or whether it's hosted in cloud or on-premise. If it's in cloud, like where, because systems hosted in Europe versus Australia, they have different latencies. So, and if we have some components hosted on-premise and some in cloud, and if we have too many interactions, back and forth calls happening between these calls, then performance might suffer. And also understanding the physical architecture is important because we can, like some components like firewalls or load balancers or gateways, these components are only visible when we analyze the physical architecture. They won't be visible in the logical architecture. But understanding these is critical because, for example, if we don't understand what kind of load balancing policy is used or what are the thresholds at the gateways, we might accidentally mess with them during our testing, and we might run into false performance issues or things like that. So let's go to our example one more time. So let's say we have 2 nodes for the web portal and 1 for the integration, and we have a couple of nodes for the app tier for the core systems, and we have the same physical database server which is shared across both the core systems. So if we look at an architecture diagram like this, we can immediately see that, like, okay, the integration layer has only 1 node, which means if this node is overloaded or if something happens and this node crashes, there is no way that this web portal can communicate with the downstream systems and fetch the information for the students. Also, the regulatory body cannot get the information that it's looking for. So this becomes like a single point of failure. So so understanding this physical architecture, it gives us an opportunity to identify the risks and mitigate them even before we do any kind of testing. And like, okay, one more example in this case is like, we see that the same database server has been shared. There might be different databases, but it's hosted on the same physical box, which means performance issues with one system, like the disk issues, could impact the performance of the other core system, which is again a risk that we can raise and we can come up with a way to mitigate it. Also, another key piece of information that we typically can get by looking at the infrastructure is the differences between the performance test environment as well as the production environment. So we can get information like the sizing, the specs, and the number of nodes, the differences in number of nodes between the performance test environment as well as the production environment. Because this information, it helps us make sure that our tests are accurate and realistic. Also, like in my experience, something I have seen quite often is that sometimes some components in performance test environment, they share the hardware with the components in the production environment or with other test environments. So this is also kind of risk. It's not ideal to share infrastructure with other environments, but at least if we know the limitations, we can work around them, like working out of hours or turning off some services for the other environments and things like that. So that way, instead of just blindly running the tests and then worrying and wondering later why my test results are wrong, this is more a proactive approach, and it saves us time and effort going forward. So this is about the infrastructure layer. Moving on to the next layer, it's the communication layer. So this is where we take a look at the architecture and understand how the components communicate with each other. So this could include things like what sort of network protocols used between the client and the server, and what type of network is used, whether it's a mobile data or a wireless network. Also, because this helps us determine the tooling options, what tool can be used to simulate those protocols, as well as if we need to employ any like network simulation techniques, etc. Also, when we say about the communication layer, it's not always the communication between the client and the server. The communication between the components is also really critical. Like, the example we were talking about before, like some components in cloud and some components in on-premise, depending on the network latency and bandwidth, if there are too many round-trip calls between these components, then the performance might hurt. Also, in this step, we take a look at like if the communication is synchronous or asynchronous. This could also be important because let's just see with an example. So let's take a scenario. Maybe it's the last day to submit the applications for the next semester. In that case, like all the students there might be a sudden surge, a sudden increase in the incoming load coming from the student web portal. So if that happens, assuming there is no bottleneck in this integration layer, this sudden increase in load will be pushed to the downstream systems, because all these components are synchronously connected, all HTTPS, so synchronously connected. So sudden increase in load will be pushed to the sudden increase in load to the downstream systems as well. So these core systems are under risk. But say, talking about the asynchronous communication, let's say we have a messaging system which sort of like regulates the flow of messages between the core systems. So in that case, even if like these core systems are under heavy load, it's still fine, because the messages will get queued here and will be fed into other core systems in a controlled, regulated fashion. So which probably means the rest of the systems are not under a huge reliability risk. So things like these will be, we can understand by looking at the nature of communication between the components, so we can identify the risks and we can come up with opportunities to mitigate. The final step, or the final layer in this approach, is the information layer. So this is about understanding the nature of business data exchange. Like this goes hand in hand with the previous communication layer we have seen, but communication layer, it's more about understanding the technical aspects of the communication. But here it's The focus is more on understanding the business data exchange between the components in the landscape. So this could include things like what kind of business data is exchanged, and like how many back and forth calls are happening between the components, and what is the sequence of calls happening between these components. Like, let's say if we have let's say one student can be enrolled into multiple courses, right? It could be 1:10 ratio. One student can be enrolled into like 10 different courses. So when the student web portal fetches the information about the student, let's say it makes one call to the student management system and displays the information back to the student. But when it displays courses information, say if the application is poorly designed, it might be making 10 different calls to the course scheduling system for every student. So understanding this level of information will provide us opportunities to tune, as well as like it reminds the significance of trust data setup. Like we cannot simply use dummy student accounts that are not enrolled in any courses, because if we do that, we will be missing the traffic that is going to this course scheduling system altogether. So as well as having understanding of this this detailed information between the calls happening between the systems, it makes it a lot easier when we are troubleshooting the performance issues, because we are no longer shooting in the dark. If we know something is taking longer, we can immediately like say which component or where the issue could be. So that is how it like makes it our life a lot easier doing this kind of analysis upfront. So once we get all this information, the way I do it is like I usually create my own compact version of architecture diagram with all the key findings. But there might be other reasons why you might benefit from creating your own version of architecture diagram. Is when like if you don't have any existing diagram, which happens more often than we think. And even if we have some kind of existing diagram, but if there is no end-to-end view, even then, or sometimes because architecture diagrams are drawn for different purposes, right? They might be either too detailed or too complex. So that's the reason, like, this is how I typically draw my own concise version of architecture diagram, which has the information like network protocols, or I color code based on the changes, whether it's an existing or new component, and whether it's a synchronous or asynchronous, what kind of users, what kind of devices. So because it just makes it easier, you can anytime print this document and talk to business people or infrastructure team people. It just makes it a lot easier. So when this pretty much summarizes my talk, and before moving on to the Q&A, I just wanted to quickly talk about something. Like when I presented this similar talk previously, we had one of the interesting discussions, like because these days everyone is agile, fast-paced, right? So people are cutting the amount of documentation they are producing, the amount of details they're producing in the documentation. So which is not ideal, but if something like that happens, then what can we do? How can we get this information? So one of the solutions that was proposed was like using APM tools. Like if we have nodes, agents installed on each of the nodes in production, that kind of produces the snapshot or the dashboard on how all the components are connected. And so that is kind of an architecture documentation itself, which I thought was interesting and thought I would share with you. So yeah, thank you everyone for listening, and that's pretty much all I have today to share. And yeah, I'm happy to take any questions.
Thank you, Servali. That was a great presentation and very informative. And we did have a few questions come in.
Okay.
Some asked if there will be slides coming in or being sent. We will send a link to the recording, so you will be able to share that with other team members. And remember at the end that there is a survey. I will keep pitching that. But another question that came in was, how do you establish workload model using this approach?
Okay. Just to make it clear, so this activity we are doing, it's something that complements the workload modeling, but it's not a replacement for workload modeling. This helps us to identify the key sources of load. But again, when it comes to actual workload modeling, it depends on what sources of information that we have. If it's a web application, we usually have some sort of web service, web logs that can provide the information of the traffic. So we can use that to see how many calls are happening, which pages are getting accessed. Or if it's a brand new application and we don't have any of such logs in production, then it might be a good opportunity to talk to the business teams or the marketing teams in terms of who is going to be user and how the application is promoted, and just to get some forecast numbers to start with. So it itself is a process, and I hope that answered the question.
Absolutely. And do you feel like you need to conduct this architectural analysis every time a new functionality is added to the application you're testing?
It probably no. It depends. Like if the application is a relatively mature application or product with only minor enhancements going or minor fixes going once in a while, then this is we really don't need this. Or if you're part of an organization working with the organization for many years, maybe you already have this kind of information, so there is no need to do this every single time. Maybe depending on the functional enhancements going in, it might be worth taking a look at things like revising the workload model, but we don't need these detailed analysis. This is especially useful when we have like major transformational projects going on and a lot of components are changing in the architecture, or if you're a new consultant, or if you're going into a brand new environment to a new client site. So that's when this information may or may not be in place. So that's when this information can be really helpful doing this exercise. Yeah.
Okay. And regarding cloud environments and architecture, does a cloud architecture provide a dynamically scaling system to allow for unexpected spikes or growth?
Yes, definitely. I mean, that's the objective of scaling. This is certainly an interesting topic, like cloud and performance, because I mean, cloud environment definitely provides the scalability aspect of your software, but there are other aspects like how well your application performs over time and how fast. Because if you have a really badly coded system, it will perform bad even if it's hosted in cloud or on-premise. Maybe if it's hosted in cloud, it might be less visible because it might be consuming more resources instead of so if you actually tune the system instead of using more number of hardware resources, you might you might have an opportunity to get away with fewer number of resources if you have a well-designed, well-tuned system. So yeah, I mean, cloud definitely provides scalability aspect, but that doesn't mean that we don't need well-performing systems or no need for doing this kind of analysis or performance testing altogether.
All right. And those are all the questions we've had come in. If you need further follow-up, please feel free to visit www.testingconsultancy.com. You can reach out to either myself or Servali there. Thank you again for joining us. Please fill out the survey, and we will have the recording up by close of business Friday, U.S. time. Thanks, everyone.
Thank you, everyone.